All right. Thanks very much for coming, everybody. I think we'll have to get started because we've reached after 11:30. So thanks very much, everybody, for attending this session on software demonstrations. We've got a great lineup of talks, starting with Lucas Peak on behalf of Wouter Wieder from Leiden University. So thank you very much.
Hi, everyone. So I'm the first one to go, and I will showcase to you a software package that we developed in Leiden. It's called the ARIbrain Explorer, and I will start with one slide of theory. Then I will show you screenshots of the application, and at the end I have a video to show how it works all interactively. Yes. So the software provides true discovery proportions of clusters. It's a clustering algorithm. And why is this the case? Well, the hypothesis that we test with standard extent threshold clustering is that at least one voxel in that cluster is active. And so we therefore do not have high spatial specificity, especially in large clusters, as to where the signal originates from. So true discovery proportions provide a formal way of mitigating that spatial shortcoming. And so TDP is a way to quantify the amount of spatial uncertainty. So for instance, we can say at least 60% of the voxels in this or that cluster are active. And so this allows researchers to drill down into certain clusters and find out with more certainty where the signal originates from. So what is the ARIbrain Explorer? It's a software package to analyze statistical brain maps, so Z, T, F, and p-value maps. And it combines the performance of C++ with a Python-based interface. And so the C++, the backend, solves the spatial specificity paradox. And the UI, as you will see shortly, allows to interactively test and adapt any cluster or subclusters' TDP values. It features real-time 3D rendering of the clusters in a template brain. We show dynamic map overlays, and we have features like anatomical atlas integration. So a small disclaimer, it's the first beta version that is now live. It's on GitHub, it's very easy to download, but it also means that we're still expecting minor bugs. Maybe we did a lot of testing and we feel confident, but of course it's possible that there will be bugs. So any feedback on bugs, warnings, and user experience is more than welcome. So once you download the app, you launch it from the terminal, you call ARIbrain, and it opens the first window. Here you can start a new project, or you can load a previously saved project. So let's start a new project, as we're all new to this now. Here we basically load our data, so a statistical file. In this case, it's a Z-map. We select the file type. In the background, we try to determine what the file type is, but sometimes that information is missing from the header, and then you're asked to set it manually. And we have the option to select a background, a template image, or the raw data itself. So in this case, we have selected an M&I template T1 image. And so when you press next, the software will right away engage in the bulk of the analysis, which will look like this. So what happens during this time is that we pre-compute the solution space. So it builds a complete hierarchical tree of all the voxels in the brain, linking them together based on their proximity and statistical values. Then calculates the TDP of every single potential cluster within that hierarchy. And finally, what we show you first is a gradient map. We do that by allocating each voxel with its highest TDP possible, so the highest TDP value of any cluster that it belongs to. And that looks like this. So here you also have the main body of the interface. So I want to just walk you through it quickly before I start talking about it. So here on the left side, we see the statistical data that we just loaded. It's the Z-map. We can add more, and we can toggle between different analyses while we're in the session. Here we can select different templates, so you can upload your own. That's a feature that's coming in the near future, or use some of the defaults. And currently we have one atlas, anatomical atlas, integrated, which is just the AL2, and basically it allows us to say, okay, wherever you point your crosshair, this is the estimated region that you're looking at, anatomical region. So this is the orthogonal view. It works like any other. So you can just explore the brain, go through the images. We have a 3D clustering view. Once you start interacting with the clusters, so first I will show you in a second, we're going to go into a clustering routine. And if you want to interact with the clusters, those clusters are printed or graphed in this glass brain, and you can interact with it, and it can rotate, etc. So here we interact with the software. We set a whole brain TDP value. So here we do the initial thresholding. We have different thresholding possibilities, as you will see in a second. Then once you have thresholded, you want to interact with possibly with the clusters that remain. And there you can change the TDP values and shrink them and enhance them as you like. So here you would put the TDP thresholds, 0.75. You can use the slider, or you can use the plus and the minus button, and hitting enter or run will initiate the analysis. Here we just have some data information, and once you start selecting clusters, as you will see in a second, those are loaded in the selected cluster workstation, and then you can modulate and adjust them as you want. We have a messaging window. That's how we communicate with the user. So if there's errors or they make mistakes, or you can see it there, or we show the settings of the statistics, etc. So we have TDP-based clustering. We also have Z-based clustering, which is the more standard way. And in the near future, there will also be an anatomical atlas possibility, where it will determine the TDP values of those anatomical regions in the atlases. So now we hit the run button. So we have the clusters here that remain, and then you can start to interact with it. So importantly, what happens then after this, the clusters appear in the statistical table, which is here. This is fully interactive, so you can click on it, and the crosshair will jump to the right cluster, or you can select clusters from the orthogonal view. And as you see here, those clusters are then also plotted in the template brain in three-dimensional space. Importantly, that cluster is then loaded here, as I said, and now you can sort of change the local threshold of that cluster as you want, either, and lowering the threshold will increase its size, and increasing that threshold will decrease its size. You can enlarge it, and you can rotate, zoom in. You have different options. Different features are linked to this package. Yeah, so if you increase it, that's then it dynamically updates the cluster size. You can add another data set. So this one is then projected onto its own raw data background. Looks like this, so you have different values, obviously, and then you can toggle between the two different data sets if you would like to. Finally, you want to either save your project. Here you can also load a pre-existing project, and you can export your results. If you export your results, you select a directory, and there you will see the output. So you have a screenshot of the last selected cluster. You have a cluster map, and the table, the TDP table that we saw earlier. And we provide a full report in HTML, which looks like this. So here we have just a little explainer. You have the statistics right here in different tabs. So that's one and that's another. And we provide a screenshot of the sort of as an example of what you were working on. Here is a little video. Hopefully it will. Awesome, yeah, thank you. So it will just basically show you what I just explained, but then you get a better feel for how it works interactively. So we just did the thresholding. We go to the cluster table. We navigate the brain. We select the current cluster. It highlights in the table. It's plotted in the cluster viewer. We can rotate, inspect, set different orientations. And then we can adjust the TDP threshold of that cluster. As you saw, it was increased, so it's reduced in size. It jumps on the table in a different order. We might want to go for another one, and I think I don't see the clock. But okay, so it goes on a little bit, but it's basically what I explained before. So that is our software package, ARIbrain Explorer. If you're interested in the methods or the application, then you're welcome at our poster, 1558, today. If you're interested in the software, you can scan the QR code, and that leads you to the GitHub page. Thank you.
Thank you, Luca. Any questions at the microphone? Otherwise, please remember to use the app for our speakers. Maybe I can ask whether you are looking at the option in the near future to extend the software, the approach to surface-based clustering. So for those of us who do cortically constrained imaging, would that?
I mean, I think that's an interesting suggestion. I don't think we've talked about it yet, but
Methods is slightly more difficult for surface-based.
Yeah, that's what I can imagine. Yeah. Okay.
Nice.
All right. Anything else from the crowd? If not, let's thank Lucas again.